From the moment a jetliner pierces the sky, carrying hundreds of people across oceans and continents, it represents the culmination of one of the most complex and ambitious achievements of human ingenuity. To the casual traveler looking out the window, it may seem like nothing more than wings, engines, and a comfortable cabin. But the story behind how that aircraft was born is far more intricate, far more dramatic, and far more awe-inspiring than most will ever imagine. This is the untold journey of how a plane is made, from a sketch on a drawing board to a soaring machine of the skies. It begins not in a factory, but in the quiet offices of designers and engineers who dare to imagine the future of flight. Every new aircraft starts as a dream, a vision of greater speed, higher efficiency, better safety, and improved comfort. A team of aerospace engineers, aerodynamicists, and computer scientists spend years studying what the next generation of flight should be. They ask questions that are deceptively simple. How can we move people faster and more safely? How can we consume less fuel? How can we build an aircraft that lasts decades, surviving millions of miles of punishing use? And how can we ensure that passengers, once seated inside, feel at ease and at home as they travel across the globe? From those questions come designs. A single curve on a wing can take months of computer simulations to perfect. Supercomputers test the invisible dance of air molecules around the fuselage, measuring drag, turbulence, and lift. Engineers send their designs into wind tunnels where scaled models are battered by high-speed winds. Every fraction of a degree matters, because in the world of aviation, small changes mean massive differences in performance. The design phase is not only about art and science, but about compromise. A stronger wing might weigh more. A lighter material may be less durable. Safety, speed, weight, and cost. These four elements pull in different directions, and finding the perfect balance is an engineering art form. Once the design is finalized, the journey of manufacturing begins. What was once a digital model must now be transformed into steel, aluminum, titanium, and carbon composites. The modern aircraft factory is unlike any other production line on Earth. It is a cathedral of engineering, miles of assembly halls the size of small cities, filled with cranes that can lift entire sections of airplanes, and workers whose specialized skills have been honed over decades. The first step is building the skeleton, the fuselage. This is the tubular body of the aircraft, the frame that will carry passengers and cargo. Giant panels of aluminum and advanced carbon fiber composites are shaped, curved, and joined together with thousands of rivets. Automated robots and human hands work side by side, for there are moments when only precision guided by human intuition can ensure perfection. The fuselage is not simply a tube of metal. It must endure pressurization cycles that simulate climbing to the height of Mount Everest and then descending back to sea level over and over, thousands of times across its lifetime. If a single flaw is overlooked, the consequences could be catastrophic. That is why every joint, every rivet, every seam is inspected, x-rayed, and tested under conditions harsher than anything the aircraft will experience in the skies. Then come the wings, perhaps the most iconic feature of any aircraft. Wings are more than appendages. They are the very essence of flight. They must generate lift sufficient to raise hundreds of tons into the air, all while being flexible enough to bend gracefully in turbulence, yet strong enough to withstand immense aerodynamic forces. Constructing them is a delicate balance between strength and lightness. Advanced materials, some of which are stronger than steel but lighter than plastic, are layered and molded into wing structures. Hidden within these wings are fuel tanks that hold tens of thousands of liters of jet fuel, and intricate systems of hydraulics and electronics that control flaps, ailerons, and spoilers. The precision required here is astounding, because a miscalculation of even a few millimeters could affect the balance of the entire aircraft. But the wings alone do not make the aircraft fly. At their core lies the beating heart of aviation, the engines. To see a jet engine up close is to witness one of the most extraordinary machines ever built by humankind. A turbofan engine is a cathedral of metal blades, rotating at thousands of revolutions per minute, drawing in air, compressing it, mixing it with fuel, and igniting it in a controlled explosion. The result is pure thrust, powerful enough to propel a fully loaded aircraft through the sky at nearly the speed of sound. Each engine contains thousands of precision components, from titanium fan blades capable of withstanding bird strikes, to ceramic composites that endure temperatures hotter than volcanic lava. Before they are ever mounted on a wing, engines undergo grueling tests, pushed to their limits in fiery chambers, blasted with debris, frozen, and even deliberately made to fail, because only by pushing them beyond endurance can engineers guarantee that, in normal use, they will perform flawlessly. As the fuselage and wings come together, the assembly line begins to resemble a recognizable aircraft, but the work is far from over. The nervous system of the plane, its avionics, must now be installed. Miles upon miles of wiring are threaded through the body, connecting cockpit controls to sensors, navigation systems, and safety mechanisms. The cockpit itself is an extraordinary blend of tradition and innovation. Where once hundreds of dials and gauges cluttered the instrument panels, now sleek glass displays powered by advanced software allow pilots to monitor everything from fuel flow to weather radar with a few glances. Autopilot systems, once simple aids, now act as highly advanced co-pilots, capable of flying entire routes, adjusting to turbulence, and landing with near-perfect precision. Yet, for all this automation, human pilots remain at the center, because the final decision, the ultimate responsibility, rests with them. Meanwhile, deep inside the aircraft, teams begin to shape the environment passengers will experience. The interior of a plane may appear to be simply rows of seats and overhead bins, but it is in fact a carefully engineered space where psychology, comfort, and efficiency converge. Seats are not just chairs. They are designed for maximum comfort within the tightest possible dimensions. Lighting is calibrated to reduce jet lag, shifting through hues that mimic the rising and setting sun. Airflow systems ensure that every breath passengers take is clean, refreshed multiple times per minute. Entertainment systems, touchscreens, and Wi-Fi antennas are carefully integrated into the cabin without adding unnecessary weight. In these small details lies the difference between a long, exhausting journey and one that feels effortless. But before an aircraft can ever be allowed to take a single passenger on board, it must prove itself worthy of the skies through a gauntlet of tests more severe than any real-world conditions it will ever encounter. Engineers subject the fuselage to extreme pressure tests, filling it with air far beyond normal operating limits to ensure there are no leaks or weaknesses. Wings are bent upwards until they almost touch in stress tests, verifying they can endure turbulence more violent than any thunderstorm. The entire aircraft is exposed to temperatures ranging from the searing heat of deserts to the freezing cold of the Arctic. It is doused with artificial rain, struck with simulated lightning, and even tested against bird impacts. Finally, the most dramatic test of all, the first flight. The rollout of a new aircraft is a moment of immense pride, anxiety, and anticipation. Engineers, designers, and workers who have dedicated years of their lives watch as the plane is towed from the hangar, its gleaming body catching the sunlight. Pilots step aboard, aware they are about to trust their lives to a machine that has never before taken to the sky. As the engines roar to life and the plane begins its taxi, silence often falls across the crowd. Everyone watches, hearts pounding, as the aircraft gathers speed along the runway, faster and faster, until at last the moment comes. The nose lifts, the wheels leave the ground, and the plane ascends into the sky. In that instant, the dream becomes reality, and years of effort are validated in the graceful arc of flight. Yet even then, the journey is not complete. The aircraft undergoes hundreds of hours of flight testing. It flies through storms, across mountains, and on long-haul routes to prove its endurance. It executes emergency landings, engine shutdowns, and other worst-case scenarios under the watchful eyes of test pilots and engineers. Every result is meticulously recorded, analyzed, and refined until the aircraft meets the uncompromising standards of aviation authorities. Only then, when regulators are satisfied, can airlines take delivery and the aircraft begin its service in the skies. When passengers finally step aboard, most never stop to consider the immense story that brought this aircraft to life. To them, it is a vehicle, a way to travel from one city to another. But hidden within every bolt, every panel, every polished wing, are countless stories of the workers who riveted its frame, of the scientists who tested its aerodynamics, of the pilots who risked their lives to prove its airworthiness. It is a global effort involving tens of thousands of people across continents, each contributing a piece of the puzzle, each ensuring that the final product is as close to perfection as humanly possible. The story of plane manufacturing is, at its heart, the story of humanity itself. Our relentless desire to push boundaries, to connect with one another, to shrink the distances that separate us. Every aircraft is a symbol of progress, of dreams made real through science, discipline, and daring. And every time a plane lifts from the runway, disappearing into the clouds, it is a reminder of what we are capable of when imagination meets engineering and when determination meets the endless sky.